For activity 4.4, we'll skip ahead to part 5, where we're asked to graph an exponential function with a given given dimensions for a viewing window. So in Desmos, what we can do is enter in our given function, y equals 2 to the x, and then using the wrench icon, input our viewing dimensions, which would be already negative 10 to 10, and then for y, we would want negative 2 to 10. In part C, we're asked to determine the y-intercept of the graph, which you can do by substituting in 0, or just as a review, or to verify, if we click on the curve, then we can see highlighted in gray any intercepts, including x-intercepts and y-intercepts, as well as points of intersection with other graphs. This also helps us answer part 7. So we see the y-intercept being highlighted, but we never see an x-intercept being highlighted. And we can continue to sort of scroll down our graph or click and drag down our graph, and we would see that our curve never actually ends up crossing the x-axis. What we are asked to do then in part 7b is create a table of values for this equation. So in place of y here, we'll input 2 to the x1, and then input the different given values for x. What we're asked to do then is answer what's happening to our function value as our variable x becomes more negative, or as it continues to decrease, and we can start to see that pattern emerge that we're getting something that is closer and closer to our value of 0. Actually, moving ahead one more page here to question 11, we're asked to complete the following table. So now we have a new function with new values. So we could go ahead and again hide any previous results and insert a new table where in place of y2 we'll input 1/2 to the x2, and making sure that we're referencing x2 rather than our x1 values that we set up in that first table. With our table of values completed, we can see that pattern starting to emerge from the graph of 1/2 to the x. Then in part C, we're actually asked to graph the equation itself, which we'll see overlapping exactly with the points that we just plotted. And if we want, we can change the color just to have that corresponding nature between the curve and the points. And then in part E, we're asked to again determine the y-intercept, which if we have our line highlighted, if we've clicked on it, we'll see that gray point, and we can identify our y-intercept as the point 0, 1. In question 13, we're asked, similarly for this example, if our function has an x-intercept, and then we're asked to complete the following table. So we're still using that same function, y equals 1/2 to the x. We have some x values that we'd already plugged into our table, but 2 new values to add in. So rather than actually recreating an entirely new table, we can simply click below the 5 in this existing table and add a value of 7 and then a value of 10. So building off that previous work, we can get those remaining results and see that pattern of our function value heading to 0.